All right, in section 8.2, it's called the reciprocal family of functions. And what we're going to do is we're going to take this function right here, 1 over x, and we're going to manipulate it. So let's look on the graphing calculator here first. Turn the calculator on, go in and type in 1 divided by x. Yay! And we're going to graph this. Let's see, I'll do zoom and number 4 decimal, zoom decimal. So that's your basic graph. Now how can we change this graph? Well, we can do h and k type things like with parabolas. So I'm going to put in parentheses here, second shift, and then parentheses x minus 2. And then hit graph. Oh, I want to compare it. I'm going to put in 1 divided by parentheses x minus 2. All right. So I'll have a red one and a blue one. Graph. So here's the original. And here's the new one. So as you can see, it's the same shape. It just got shifted over 2 spaces to the right. And that matches what h does with parabolas. Now if I want to move it up, I can do like plus 4. So now it'll be 2 to the right and up 4. So there's the original, the parent function. And moving it up 4 really made it almost go off the screen, didn't it? In fact, you can't see it. So I'm going to do a different zoom. I'm going to do zoom standard, which is number 6. So there's the original. And it's 2 spaces to the right and a 4 up. So you can see it's moved up quite a bit. And now we can change this number on top too. I'm going to change that to a 6. That will make it be a lot more compacted, I believe. So looks like it's more stretched out. It's really hard to tell unless they're like side by side. So let's look at how it changes it side by side. So I'm going to put the 6 here. I want to get rid of these. Delete, delete. Get rid of this. Delete, delete, delete. So let's put them like side by side. So it made things push out more away from the origin, is what it did there. And then of course you could go closer to the origin too, right? If we change this to a decimal, like 0.5, second, insert 0.5, delete, so now it's a half there. And it should be closer to the origin. So we're changing how it's smushed and stretched out. So here's the basic idea. It's y is equal to a over x minus h plus k. And the k moves the function up and down. And then the h moves it left and right. And then the a is the smush factor. So, well, it says right here it's a stretch if it's bigger than 1. It's a shrink if it's less than 1, and then it flips over the x-axis if it's negative. Okay, so they're calling it a stretch and a shrink. So it's the smush or the non-smush factor that the a does there. All right, so let's graph this one. There's no h and k, so my vertical and horizontal asymptotes are just 0, 0. So y is equal to 0 is the boundary this way, and x equals 0 is the boundary this way. And now we just have to figure out the smush factor. So and then the negative here. Well, normally this curves in this quadrant, the first quadrant and the third quadrant, but the negative is going to flip it over, so it's going to be in the second and fourth quadrant. Let's plug some numbers in here to see the smush factor, or the stretch factor. Actually be a stretch, wouldn't it? So I'm going to put in 1, and I get back -3. So 1 and then down -3. 1. Let's see, 1 down 1, 2, 3, and then I could put in 3, and then I get -1. So it's 1, 2, 3, down 1. So it's smushed in this area right there. And then do the opposites over here, and it should flip here. So I'm going to put in -1 now. If I put in -1, I get 3, and putting in -3, I should get 1. So it'll be over here. 1, and then 1, 2, 3, and then 3, -1, 2, 3, up 1. So this would be a stretch away from the origin. So it stretched it out this way instead of compacting it in, which would be a shrink. So we're calling it shrinks and stretches. I don't really get too worried about that. If I always can plug some numbers in and kind of feel where it is. So that's how I kind of judge A, is by plugging numbers in and then graphing it and go, hey, it's different than the original. Okay, example number 2. Oh, we're supposed to state the domain and the range on this one. So state the domain range. So the domain is all real numbers except x equals 0. So you can't put 0 there because you'd be dividing by 0. That's a problem. And then no matter what numbers you put in, you never can get y is equal to 0. So the range is all real numbers except y equals 0. So the horizontal and vertical asymptotes kind of create the domain and range of the function. Alright, this one here is 1 over x minus 2, and then plus 3 is equal to y. So this is our next example to graph. 2, the h is 2, so it's moved over 2 spaces to the right. And then the y equals, or the k back here is 3, so it's up 3 spaces. Normally it goes the 0, 0 is your horizontal vertical asymptote, but on these now it's shifted up 3 and 2 to the right. So the domain is all real numbers except x equals 2, and then the range is all real numbers except y is equal to 3. Okay, and then there's my y equals 3 and my x is equal to 2. Those are my boundaries. Now, plugging in some points. I'm going to pick points on each side of 2 to figure out where it curves here. Now it's going to be a normal shaped curve. There's no stretch or shrink because A is 1. So picking some points just to make sure that it's okay. I'm going to pick not 2, I'm going to pick 3. So if I pick 3, that's going to be 1 divided by 1 is 1, so it'll be 4. So 3, 4. 1, 2, 3. 1, 2, 3, 4. So it curves in this section right here. I know that because it's just like the original graph, it just shifted over. And then I'm going to pick 2. No, I'm not going to pick 2, I'm going to pick 1. And that would be -1 divided would be -1, and then it'd be 2. So 1, 2. So there it is. On this problem here, we're given the graph, and we're supposed to write the equation. Now it's a translation of 1 over x. So I don't have to guess what a is. A is kind of figured out for me because I said it's 1 over x. So I just have to put the h and the k in. Well, this is over 1, 2, 3. So x is equal to 3. And then this is down 1, 2, 3, 4. So y is equal to -4. So it's 3 to the right. So it's y equals 1 over x minus 3. That moves it 3 to the right, and then down 4. All right. So this section here is all about manipulating this original equation here. So here's the original equation, and we just shift it around, left, right, up, down. We stretch it, we shrink it. The A, the H, and the K we're changing. If A is a big number, it's a stretch. If it's between 0 and 1, it's a shrink. And if it's negative, then it flips it over and it curves in the other two quadrants that are not normally used when A is negative. So we did one where it flips and it stretched it out, and then we just did a normal one where it's just moved, shifted 2 and then 3.